Hi, this is Maggie from Design Code Debug Repeat. Welcome to the channel. If you're here because you want to learn to program in Java, you're in the right place. This is the lucky 13th video in the Introductory Programming in Java full course and the 4th video of Lesson 3, Branching Structures in Java. In prior videos, we took a general look at conditional statements in Java, and then we looked at creating Boolean expressions with relational and logical operators and comparing strings using .equals and other methods. In this video, we're going to look at Boolean variables and some of the common patterns you see with setting and evaluating them. Let's get right into it. Boolean variables are tricky for some new programmers, but with practice, you'll soon be using them with ease. I think they take getting used to because most people don't have a lot of experience with logical expressions in their K-12 math classes. Let's think about Boolean variables in terms of how we use them. A Boolean variable is usually used as a flag, an indicator that a condition is present. Remember that a Boolean is either true or false, so this is a yes or no, on or off, present or not present sort of indicator. For example, were any of the inputs invalid? Were any of the grades 100s? Are any of the diners museum members? Is the student graduating this year? Etc. And then you'll test the flag before taking some action. So for example, if any of the inputs were invalid, don't process the inputs. If none of the grades were 100, scale the grades. If any of the diners are museum members, discount the meal. If the student is graduating this year, order a cap and gown, etc. Let's look at some typical ways that Boolean variables are set and tested. This program is called binarypuzzle.java. And it randomly generates a number between 1 and 1000, generates its binary equivalent as a string, and asks the user the binary equivalent of the number. It can then compare the correct string with the user's string, using .equals, of course, and stores the result in a Boolean variable. It then tests the Boolean variable to print a message telling the user if their answer was correct or not. There are a few little things here you might not have seen before. The random class, which can be used to generate random numbers, and the integer.toBinary string method. I want to point those out without focusing on them. You may assume they do their jobs as described. So I'll run it. And it asks, what is the binary equivalent of the decimal number 889? And I'd like to figure this out. So that's 1 in the 512's place, and we have 377 left. So that's 1 in the 256's place. So we have 121 left, which is not enough for the 128's place, so we'll put a 0 there. A 1 in the 64's place, and we have 57 left, so a 1 in the 32's place. And we have 25 left, so a 1 in the 16's place. And we'll have 9 left. So a 1 in the 8's, a 0 in the 4's, a 0 in the 2's, and a 1 in the 1's. So that's 1, 1, 0, 1, 1, 1, 1, 0, 0, 1. Okay, I got it right. Let's run it again, and I'll get it wrong. What is the binary equivalent of 210? I'll type 1. Okay, and it says wrong, the binary equivalent of 210 is 11010010. So you can see it has two different behaviors depending on whether the user types in the correct conversion. Let's look at how that's achieved with a Boolean variable. First, on line 13, the variable is declared. The data type of a Boolean variable is Boolean, lowercase b, and it is a primitive data type. Quite often, Boolean variables are named so that a conditional statement with the variable will read almost like a sentence. This variable is called isCorrect. When we later write if isCorrect, it's almost natural language. The conditional code that follows will execute if the answer is correct. On line 31, isCorrect is assigned a value. This is going to be true or false. On the right side of the assignment statement, we're invoking the .equals method on user answer, passing in binary string. We could have done that in the opposite order too. We could have sent the .equals message to binary string and passed in user answer. Remember that this will evaluate to true or false. Whichever it evaluates to is assigned to the variable isCorrect. Now, you might feel more comfortable writing something like if user answer.equals binary string isCorrect equals true, else isCorrect equals false. It's not wrong to write the code that way, but once you are more comfortable with Boolean expressions, you'll see that it's executing an unnecessary test. In that code, if the test is true, we're assigning true to the variable. And if the test is false, we're assigning false to the variable. Better to just assign the result of the test to the variable. Now, on line 34, we have the test. So remember, there will be two things we do with a flag: set it and test it. On line 34, we have an if statement, and the condition is simply is correct. A Boolean variable is a relatively simple Boolean expression. It evaluates to true or false. So we only need to write the variable name here. You might feel more comfortable writing if is correct equals true. But that's a very bad habit, and I'll tell you why. It's far too easy to accidentally write if is correct equals true. And guess what? Many languages will let you make that mistake. Look, Java thinks it's just fine. Python won't let you do it, but many languages will, with the idea being that you know what you're doing, and so you must have meant to do that if you did it. But we usually don't mean to do that. And that's a hard one to debug. That's an assignment statement. It won't matter what value is correct was previously assigned up on line 31. If we write if is correct equals true, it will be assigned true. And then that assignment statement will evaluate to true. So the code will always execute, and we'll have changed the value of the flag. So try now to get in the habit of simply writing the Boolean variable after the if. And that's it. If the Boolean variable is true, that means the user's answer was equal to the correct answer, and the conditional if code executes, printing the message that the user was correct. And if the Boolean variable is false, it means the user's answer was not equal to the correct answer, and the else code will execute, printing the message that the user was not correct. Let's look at a different sort of pattern. This program is called averagealtitude.java. It asks the user for the altitude of 3 mountains. If the user enters 3 positive non-zero values, the program will calculate the average altitude. But if the user enters any negative or 0 altitudes, the program will respond with an error message. I'll run it. And first enter 8848. That's the height of Everest in meters. And then 5895. That's Kilimanjaro. And finally 1338. That's Mount Mansfield, the highest mountain in Vermont. That's one I have a chance of visiting. And the program responds with 5,360.3. Now I'll run it again, and I'll just give one negative value. So I'll type the same values, but I'll put in -1 for Kilimanjaro. And I get an error message. Now, the way this flag is set is a little different. When the variable has non-positive value is declared on line 12, notice that it's given a default value of false. So here we're assuming that all of the values will be positive. But after we obtain each value on lines 19, 26, and 33, we check with an if statement. And if a value is less than or equal to 0, we set that flag to true. We can't set this flag the way we set the other one, by setting it to true if any of these is non-positive and false if any is positive, because then we might not catch a negative value. If the first or second is negative, but the third is positive, the third if statement would set it back to false if we did that. So we need to give it an initial value and then change it if one of the values is bad. You can do this either way, set the flag to false and then set it to true if any condition is met, or set it to true and then set it to false if any condition is met. It just depends on how you plan to use your variable. We could also have called it all positive, set that to true, and then set it to false if any were negative, but our test at the end would be different. So at the end here, we're checking if it's still false. If not, has non-positive value. Then we're computing the average, and else we're printing the error message. So we use the first pattern from binary puzzle when we're setting the variable based on a single test. We set the variable to true or false depending on whether the user's answer matched the correct answer. But we use the second pattern, giving the Boolean a default value and then possibly changing that value, flipping that switch, in multiple places when there are many opportunities to set the flag. And with that pattern, you want to make sure that your initial value and the test you're using at the end work properly together. In this example, a false flag means that no errors came up, but you could as easily write it so that a true flag means no errors came up, setting it to true and flipping it to false after each test. One way or the other might read more naturally to you, and so choose that way. Okay, so as usual, I have included some auto-graded exercises in the description of this video so you can practice with both of these programs. If you get stuck, come back and watch the video. And as always, these code examples will be available in my GitHub repository. I urge you to come up with your own examples, maybe based on the use cases I listed at the start of the video, and program them with Boolean flags for practice. When you're feeling confident with the concepts in this video, you're ready to move on. As always, have fun and keep coding.